Hello, and welcome to part 2 of Epic GitHub tutorial on contributing to UFS and Epic repositories. My name is Natalie Perlin, and I work on NOAA Epic project. So part 1 of the tutorial could be accessed following this link, and it could be also found on NOAA Epic website under tutorials menu. All the materials for the presentations could also be found on GitHub in NOAA Epic account under Training GitHub repository. You can get all the materials and tutorial presentation using the command line and doing git clone, giving the address of the repository. When you go into Training GitHub directory, you will find all the materials there. So briefly recapping part 1 of the tutorial, we covered some Git and GitHub basics, terms and concepts, differences between Git and GitHub, looked into Git configurations and commands. We gave an example of setting up a SSH key pair for GitHub authentication. We looked into creating, initializing, and pushing new repository to GitHub. We made some modifications, commits, looked through the logs, then made a new branch, compared branches, and started a topic on public GitHub repositories, and started to talk about forks and clones. So in this part 2, we'll continue looking into remote repositories and how to contribute to UFS and Epic. We'll continue talking about forks and clones, looking into the differences and which roles do they play in the process. We'll look into branches and tags and the important differences between them. Look into Git workflow, navigate local spaces that need to be understood well in order to communicate with the remote repos efficiently and correctly. Then we'll be fetching and merging remote branches and local branches. We'll be resolving merge conflicts, making pull requests, and look into GitHub issues and discussions. So there is a fair number of GitHub repositories used by UFS community. They all hosted on GitHub, but not all located under UFS community account. Some of them are under other accounts, and some of them have other repositories as dependencies. Now we'll talk about forks and clones. Fork is a separate copy of another existing repository that is created in a remote location, for example, GitHub account. On the cartoon, so we have repository A, for example, it's UFS repository and under UFS account, and if you fork it, you make a separate copy of this repository under your GitHub account, and let's say it will be repository B. You could sync it with repository A with a primary repository, or you can also keep it separate as separate work and keep working without affecting the original repository. The fork is done using GitHub dashboard. So you'll find a fork, create a fork, and then you would see a note that it's forked from and the account name. Clone, on the other hand, is a linked local copy of an existing repository, and it is download it to your local machine. It is done either through git clone, or sometimes you could use the um, graphic interface editor, GUI editor. It also has a reference to the original repository, so it keeps the reference. It is done via git clone, so here is an example of cloning the repo. And when you query the remote, git remote -v, getting some more verbal output, you would see the local name given to this repository and the address. Git branch will show you the local branch. It is usually the default branch of the cloned repository. So the outline how we contribute to GitHub repository, open source of GitHub repository. First, we make a fork of this repository to our GitHub account. Then we clone it to a local machine. Then we make changes, push it to our GitHub repository, push it back. Then we sync our changes, local changes, with the GitHub fork. And then we create a pull request, which means that we merge our changes or ask to merge our changes with the original repository. And repository owner would make a decision, may request to do some changes or suggest some edits or improvements. And after it's all the comments are addressed, the repository owner can merge it into the main repo. Briefly, the diagram could look like this. So this is the original repository on GitHub. When you fork it, you create a repository, fork repository under your GitHub account. Then you clone it from there and you bring it to your local system. Then you make changes, and when you're happy with it, make changes and commit them to the repository. Then you push them back to your GitHub account, to your fork repository, and make a pull request into the original repository. So let's talk about branches and tags. These are concepts of Git and GitHub, and branches mean branches used for concurrent development, bug fixes, some implementation features. Branches can be moved or deleted. They often could be expected to be merged back into original branch. However, the feature branches could have a longer span. It could be release branches or some features for other particular machine or anything else. Tags usually mark a specific point in history to capture versions of your package, and they typically used to make a stable points that correspond to specific releases. They, however, are permanent and do not change after they are created. And this is because they used to label a specific commit. So they point to the commit that is that is in the log file. So it points to a particular time when this commit was made. So let's look into the diagram of development of any repository. For example, we have the main is master branch. We decided to make some feature branch, did some changes, merged it back into master, and decided that it's good enough for release version. Make a release branch and give it a tag, specific tag. Then we decided to add another feature to the repo, merged it back to the main repository, then merged it to the release repository and gave it another next tag number. There will be next feature 3 used in the development, and then it merges back to the master, but at the same time the bug was found in the specific commit, and it was fixed. There was a quick bug fix, quick branch for bug fix, merged back into the release, and eventually it was also merged into the master. And then all of the commits will eventually merged into a release branch and have a final tag number. So now we'll look into local areas of Git. It's important to understand the distinction between these 3 stages that local Git has, because most of the work you will be doing with the code would be on your local system, not on GitHub. So you would need to understand how Git specifies and uses each of its spaces, each of its 3 stages. First is the working area, which is your local directory that contains all untracked, unstaged, and locally deleted files. There is a staging area that has index of the files that need to be committed, that do not need to be committed, or any new files to be added or removed. The local repository, that is also sometimes called head, are committed changes and also contain the latest checked out version of the remote repository, and I labeled it here origin master, and the slash means that this is the reference. So origin is the remote repository and master is the branch of the remote repository that is synced with, or is being synced upon request with the origin remote repository and master branch on that repository. Head means it is a symbolic reference to the branch we are working on. So this is where the where we currently put our head into. Head also points to the branch, but the branch itself points to the most recent commit. And we will look a little bit more into the head term. So we'll get some examples on Git workflow to understand this concept better. And first we'll use the online visualizer tool, where we'll look into one simple case with just divergent local branches. We'll merge and update the local repository. In case 2, we will be looking also on concept of detached head. What does it mean? On rebasing and merging the branches, bring upstream branch changes, and we'll also update the remote repo. Next, we'll be using some existing UFS repository, so existing authoritative repository, and test some real case scenario and play a little bit with repository code. We'll fetch and merge remote branches, update the fork repository, we'll make some changes, merge them, resolve merge conflicts, and eventually we'll make a pull request into the authoritative repository. And the third interesting case, we will be testing somebody else's PR, giving feedback, and even making our own PR into another developer's code. So let's look into case 1. So in the case 1, we'll have on the right, there is a remote origin repo with a master branch, and we have its clone in the remote repository where head points to master branch, and origin master represents the latest sync with the remote repo. So let's introduce some commits, git commit, and create 2 divergent branches at this point. Git branch 1, git branch 2, then let's go back into branch 1, git checkout 1, let's do a couple of commits there, git commit, and go back to branch 2, introduce changes there, git checkout 2, git commit, and we can start bringing these changes into master. So for that we need to go back to the master, git checkout master, and then do merge, which brings the new commits into the master and thus advance the master. So in order to merge commits from branch 1 into master, we issue git merge 1. Then, as you can see, head points to master, that is in sync with the 1 branch. And if we do git log, it will show that there is a linear history of logs. When we merge branch 2, do git merge 2, here it does contain the logs or commits from both of the branches, but it does not have a linear history. And if we do git log, we would see that they all will be there, but it's not a linear history. And we will also have a merge commit that decides what changes from which commit go into the main code. Then we can push our changes to the remote repository, but before that, it's always good practice to fetch any potential changes in the remote. So we'll issue git fetch origin master. So what it does, it looks into the origin repo and master branch and compares it to the reference, the local reference, origin master. Right now they both points to the same commit, and we also get a message fetched 0 commits on master. So now it will be safe to push our changes into the remote. So we issue git push origin master. So let's look what happened here. 2 things. First, we have our remote repository updated with the local changes, and second, on the local side, we see that the reference to the remote branch, and also advanced, also was synced with the remote, with the current remote. So now we can consider slightly more interesting case. Let's do clear. We'll consider a case with some upstream changes to the repo. In this case, we have the origin as a remote repo with two branches, master and feature. The same on clone on local repository. However, in the upstream repository on the remote, we have feature branch that is more new. It has one more commit than the local branch. So let's see how we work with the local space in this case. So we'll introduce new commit, but we'll label them this time for the better tracking. Git commit -m, let's call it my commit 1. Then we'll make two branches, git branch 1, and then do git checkout -b branch 2, which will make a new branch that is -b flag, and check into it at the same time. Git checkout -b2. Then introduce a couple of new commits, git commit, and give the message that is my commit 2, and another one, my commit 3. And then let's go back to branch 1, git checkout 1, introduce a couple of commits there. In branch 1, it will be my commit 4, my commit 5. And then instead of merging them, we can rebase. That would bring our current branch into the one we are rebasing to. If these are relatively separate features or areas where we do our changes, and we do not expect any issues or conflicts, we can do it simply by giving git rebase. So look what happens in this case. In this case, we have a linear history. Git log will show you that there is no specific merge commits. These are just commit 1 through 5. We can also consider going back in time if we want to explore a specific commit and how the code could develop from that point. We can issue, for example, git checkout and give a specific commit ID. So let me give the commit ID that is that corresponds to my commit 1. Can give git ID at git checkout, and now you see that our head now is pointing to a particular commit. And here we could do some more changes. For example, git commit, another git commit, another git commit, a more git commit. I'm doing so many commits considering that we may have done some errors, and we can go back and change them if needed. So we will introduce git checkout. It will be relative movement in space. Instead of giving a particular absolute ID of the commit, we can move relatively to our current location. It would be git checkout head -1, but instead of minus, we'll just use tilde. It will advance, or rather retreat back to the previous commit or previous 2 commits from the current location of head. So git checkout head -2, 2 commits back. Okay, now let's say we're happy with these commits, and we can go ahead and do explore our changes and do new commits. Git commit give a message that is my commit 6 and my commit 7, my commit 8, for example. And we now think that we like this, and we would like to bring these changes into the branch we work on. So as you see that in local repository, our head is defined as detached. Detached head is basically unnamed branch. So in order to bring these commits, we just give this branch a name. So let's name it git branch keep changes. Git checkout keep changes will make the head point to this branch, git checkout. Now head points to this branch. And then I suggest the following. We can go back and update the feature branch, advance it to the same commits as branch 1 has. So we'll do git checkout feature and merge branch 1, git merge 1. And at this point, branch feature would be advanced and will be synced branch 1. If we go back to keep changes, git checkout keep changes, we can also rebase this branch onto the feature branch. So git rebase feature, and this is what happens. So we have our keep changes branch advanced, if we do git log, you see that we have linear history. We would also need to advance feature with the changes, with the recent changes. So it will be git feature, checkout feature, and then git merge keep changes. Now they all are in the same location, pointing to the same commit. However, as you remember, the remote branch has one commit ahead of our reference, our local reference. So for that, we will need to fetch these changes into the local repos. So we'll issue git fetch origin feature, and note that we give origin space feature that refers to a repository and the branch, And what it does, it updates the local reference origin/feature to have the same commit as the updated remote. And then in order to advance our branch, we'll simply do git merge origin feature. Okay, now our current head pointing to the branch feature will also include this commit, recent commit from the remote. So at this point, we can push our changes to the fork or to the remote. So it will be git push origin feature. Again, we're pushing it to the origin repo and the branch feature, not to the local reference. However, look what happens when we pushed our changes. Not only it updated the remote repo, it also updated the local reference. So let's look into the steps that we've learned and recap how we contribute to public remote repositories. So we talk about creating a fork first, then we clone repository to our local machine. We add the authoritative repository for the reference and updates. We'll check out the branch that we want to make changes in. Then we make changes, make updates, make a difference. Then we'll fetch any changes from the authoritative repository. See if there are any updates to the main repo. Then we will merge changes from the update repo into our branch using the reference to the most recently synced reference to the remote repo. Then we'll push these changes back to our own fork, and then eventually create a pull request into the authoritative repo, which is also done from Git dashboard. So let's follow the example with the remote repo. It's under no epic GitHub account. It's training GitHub repo. And I already made the branch in my own account. So it will be, you can see it says forked from the repo. That way that you know it is a fork. And let's do the simple steps. Let's clone it first. Git clone and get the SSH version of the address. So copied, git clone, check into training GitHub. If we issue git remote, it will show that it tracks only origin. So we'll also add git remote, add upstream, and take the name of the original repository. It could be SSH or HTTPS, it doesn't matter. Clone. Now, if we issue git remote, it shows that it tracks both of the repositories. Git branch shows that you're tracking the master, and git branch -a will show you both remote and local. So our local reference origin master is tracked by remote origin and origin master. So then let's do checkout master, even though we're already there, but let's pretend we need to work on other branch, git checkout. The branch we are going to work on will fetch upstream master. And now what we would do, we need to merge our changes with the upstream master. Git merge upstream master. So we updated the reference and now we're bringing these changes to the reference. So if we do git log one line, that's helpful when you just need to simple one-line summaries. So you see that now heads point to the master that is also in synced with upstream master. And next we can push it, git push origin master. So we are updating our own fork. Before that, if you look at your own fork, you may notice that you have a note, this branch is one commit behind Noah Epic master branch. So when we push the changes, so what happens, it should update, we sync, that now it's up to date with the master. So it has all the commits from the master branch. So git branch -a would show us that now we tracked two remote branches, two remote repos, origin and upstream, and the remote upstream remote origin points to origin master. So let's go to the next case, which will include some changes, and for that it will be more illustrative if we use a GUI code editor such as Visual Studio Code, where we would do the commits and we'll be able to view how the local workspace changes as we switch the branches. So in the next example, we will introduce our changes, merge them, resolve merge conflicts, and then eventually upload it all to our fork. So let's get the address that we will need in order to clone the repository. Open Visual Studio. It has an option of cloning Git repository, either opening folder or cloning it from the remote repo. We will tell where we want to create it in the local drive, and then we want to open it. And here we are. We will also open the built-in terminal that will help us to combine editing the file using the editor and some interaction with Git. So we already in the repository, in the training GitHub repository, so we don't need change directory into it as we usually do after issuing git clone on the command line. So we only need to do git remote add upstream and give a name of the original repository, could be as HTTPS. And now we have two repositories tracked, remote -v, git remote -v will show us two repositories. So we are currently in the branch master, git checkout master, already in master. I usually prefer to keep master branch unchanged and be synced with the remote repository, and I work on my own changes in the separate branch. So I create a branch named feature and work into this branch, git checkout -b feature. That would create a branch and check out into it, and it's exactly the same as the master branch. Is if you issue git diff feature master, there are no changes between them. So in this feature branch, git branch, make sure we're in the feature, we'll create a new file. We open a new file and create like simple line, first commit, save it, and give it a name, for example, readme2. This will be our first commit. However, you can see that readme2 file has a symbol U next to it. That means it's untracked, so we need to add it to the repository. Git add readme2, and then we can add, and then we commit it to the repository. Git commit -m for message first commit. Okay, now our repository and branch have changed with a new commit. Git log one line. Here is the first commit. And let's create two separate branches. Git branch 1 and branch 2. Git checkout -b2. So now we're in branch 2, and we'll add some more lines to this file in branch 2. So let's put second commit and save it. And now we can issue git commit -am. A is important to add a file that has been modified. As you see, m across the file readme means that it has been modified. You can also issue git add and give the file name, but it also works by adding an option to the git commit message. Git a commit -am second commit. And let's add another one. Third commit. Let's add third commit. And now if we issue git log -1 line, you would see first commit, second commit, and okay, where is the third commit? Let's take a look. Where's the third commit? Third commit, it's unsaved. Okay, we need to remember to save it. So now it has been modified, and then we can issue the commit, third commit. Okay, then git log would show us first commit, second commit, third commit. And now we'll go back to branch 1, git checkout 1. So let's see what happens. README 2 in branch 1 has only one line, only the first line. So let's add other lines. Let's add fourth commit, save it, add it, git commit -am fourth commit. Let's do another change. Fifth commit. Save it. Commit it. Fifth commit. Now it's all updated. So now let's check git branch. We're in branch number 1 and we want to merge it with branch number 2. Git branch, git merge 2. So what happens? We have a conflict because in one case, one branch has second and third line as listed at second commit and third commit, and in other branch the lines are different. So we can merge it either by opening the graphic editor that we have here, but also we can open any text editor, open the file where we have the merge conflict, and search for the head, string head, and a name of the branch that head has a conflict with. So we will need to decide which changes to keep and also remove this additional line that marks branches and a separator. So we'll decide it. We want to have, I just open a graphic VI editor. We want to keep all of them, but let's put these two files, these two lines under the first commit, and this is the file that we want to keep. So now readme file, we saved it, but we still have to merge it. So git commit -am merge branch 1 and 2. So when we issue git log, it will show us the first commit, second, third, fourth, fifth, and merge of 2 branches. So let's see what's happening upstream in the remote original repository. So git checkout feature. We also want to advance our feature branch, because you see feature is in the commit that is many commits behind. So let's go there, git checkout feature, and merge it with 1. Git, the most recent, most advanced is branch 1, so we want to merge feature with most advanced one. Git merge, and then it merged an advanced readme file, a readme 2 file in the feature branch. And here is linear history, so we didn't have any additional merge commits when we introduce branch 1 into feature. So next, let's fetch the upstream repo, git fetch upstream master. Okay, now we updated our local reference of the upstream master. Do we have any changes? Let's see. Git merge upstream master. Yes, we want to merge them. Merge remote tracking branch into feature branch. Yeah, we can edit the merge message. It opened Git automatically because this is how we configured it in the beginning. If you remember, in part 1, when we configured, we said that we want our default editor be VI. So that's why it opened VI or Vim. That's why it automatically opened VI when it asked to record a merge message. So now git log 1 line. Here are 2 merges. So now head points to the feature, and the feature is most advanced, and we can push it. Git push origin feature. So now if we go to our branch, it will show us that we have the new branch. There's a feature. Still need to understand whether we want to merge it into master. So we say, yes, we want to open a pull request into the original repository, into the authoritative repository. So we have branch feature on our repository, and we want to merge it into master of the authoritative repository. Let's make a PR request, pull request. Let's see in our presentation where we are. So here we are at this location. We'll submit a pull request. Let's add a title, adding readme to test file. We have added a new file for testing PR. For testing pull request features. And it doesn't say it has any conflict. If it has conflict, then you will need to address them, see where the conflicts are, resolve them, and merge them. And probably you will be able to do it on GitHub. It also has capability of simple text editor, but also you would then need to bring them back to your clone on the local machine if you want it to be synced. So let's open pull request. And so in the authoritative repo, on the top menu, you would see that you have the pull request. And this is a pull request that, let's say I come as a repo owner and I look through the changes. I can look what were the commits, what each of the commits did to the repository. Go commit. Then we can go changes from one commit. Let's go conversation. We can see what files changed, and we can say, for example, either review changes and approve, or I can also add some comments. Let's leave a comment. We need a third line to say, let's third commit in capitals comment. And we also can do the same. Now you would see this note under the conversation tab, but you can also leave the note under a particular line. For example, I can click on the plus next to the line I want to comment on and add any comment. Let's say, let's go after line 2. We'll say this line needs to be second commit, and add a single comment. So what do we do with the remote repository? We'll go to our fork. Oh, no, epic. Let's see. Okay, we can update fork. We can also find the fork address under the menu here. So we go to our fork. Here's a pull request. Look into pull request, and let's see what we ask. We ask to change the second line. This line needs to be second commit. So what we can do, we'll change comment. Let's do and change. Let's go to our feature branch. Let's go to a README file, edit this file, and let's put second commit in capital. Commit changes, update README file, change line 2 as requested by the reviewer, commit directly to the feature branch, and then, as we remember, another request was done to change the third branch. We need to the third line need to be third commit in capitals. So we go back to our branch, open, this is master branch. We need to go to the feature branch. So here is training GitHub. We're in the feature branch. We go to README. We have the editor, simple editor, when we will change the third commit line, then commit this changes, update README file. Let's say third line changed as requested by the reviewer. Commit change. And now let's go back to our repo. So here the changes in the master branch are already done, and along with them the changes in the PR already done. That means if we go back to the Noah Epic repo, that we would see that in the pull request the changes, pull request, this is an open pull request, file changed, and the change has been already pushed to the PR in the authoritative repo. So whenever we make changes in our branch on our repository, if we have the PR open from our branch and we made commits in this branch, they already will be pushed to the PR in the authoritative repository. So we don't need to do any additional work. And then we go to the comments that reviewers had, and we can say, okay, this is done. We can say this is done, and all done, changes done for the readme2 file. Comment, and we can also resolve the conversation. So at this point we're satisfied. We even can respond, quote reply, is say that the line has been modified as requested. Comment, and eventually we satisfied all the comments and we merge pull request. Confirm merge, and now we see that pull request shows as closed. So the authoritative repo has no any open pull request, and it has been merged into the authoritative repo. So an important thing, we may remember to keep our local repository synced with the remote one. If we have a fork, we may need to keep it synced with the primary repository. So if you go to your fork, you would see a note possibly that it's behind the original repository's master branch or develop branch. And then you can press the sync fork button and choose to update branch. And then the note would say that it is up to date. The next Git workflow example, we will be testing another user's pull request, PR. Let's look into UFS short range weather app repository. If we look into pull request tab, we see that there are 5 open. 2 of them are still in draft form, which would still work for our testing. We will need to know the number of the pull request in order to download it and test. So it will be 1070, the last one opened by Radko, upgrade to spack-stack 1.7.0. We will follow our usual route of cloning the fork first. So this is already forked from the main repository. So let's get our SSH version of the URL. So clone it as git clone. Then change directory into this newly created repository. Add the remote repo as git remote add, and let's give it a name to authoritative repo upstream. This is the upstream, and the address will be as following, taken from the code button. So now Git will know about both of these repos. Git remote -v. So now we have origin, the private fork, and upstream, the authoritative repo. In order to check out a specific PR, we will do the following: git pull, and then give a name from which we want to check out the specific PR, which will be upstream. Then pull PR number, which is 1070. Then head column and the name of the branch on your local machine that will be you're giving the name to this branch. Let's call it 1070. So you see that it has been downloaded. Let's check git branch. It will show that we're still in develop, but we can check out into the PR branch. Git checkout PR 1070. Git branch. So here we are in the new branch. We can test it. Let's assume we made some changes, and we can either suggest some changes in the pull request site, in the pull request page, put some comments or any particular notes on the files. Could put some notes. But for now, let's consider that we made some changes and create another file. Let's call it readme2. And say that this is a test. Okay. Git status will show us that we have untracked files that we need to add. Git add readme2. Git status will show us that we do have changes that are recorded, but they still need to be committed. So git commit, give a message that adding a readme2 file to PR 1070. Okay, now we can push it to our own repository first. Git push, our own was origin, and the name of the branch was PR 1070. We didn't have any PR 1070 branch in our own repository, but now we do have it. if you look into branches, the wrong repository. Here it says PR 1070 has recent pushes 6 seconds ago. So now you have an option to making a pull request from here. If at some point this announcement will disappear, and then you can go to the particular branch. It will appear here, and choose it and then do a pull request. But for now, it assumes that we will be doing pull requests right away. So what you want to look for here is, here's the name of your branch. This is the name of your repository. And on the left are the branch and repository you want to make a pull request into. So remember that we wanted to make a pull request into Radko's branch, SS170. So we will need to find base repository Radko and choose the name SS170. Add README file. Let's put this as a test. Description on changes. Let's put test of making a PR into somebody else's repo branch. And we may ideally be a little bit more specific. In this case, I'm just giving it as an example. And you would see GitHub checking whether there are any potential merge conflicts. That will say, in our case, it just says able to merge. So when the author of the repo reviews it, they can merge it right away without changes if they find our changes useful. So, and that's it. We'll say create pull request. And now if we go to Radko's UFS short range weather app repo, you would see that there is one pull request open. And then Radko will decide what to do with it, whether to give any comments or request changes. And if he merges it, it will automatically appear in the main repository in the PR. So the files will be changed automatically after our changes merged into Radko's branch. So let's go next. Next, let's look into how we can peruse public repositories. Sometimes we would need to check out more than one repository. Some repositories may have dependencies and submodules, and you can clone all the repos right away, or you can clone a repo and then go into the directory and do git submodule update remote. Then it will pull all out all of the dependent repositories. So there are a couple of versions: git clone. Let's, for example, go into UFS weather model and pull all the entire code. Git clone recursive UFS community UFS weather model Git. We can give another name if we wanted. UFS, let's give it weather model, and then it will create a directory with this name, not the UFS short range weather app or UFS weather model, but UFS WM already exists. Okay, let's give it WM2. The next slide shows several locations on the repository webpage that could be of our interest. First is issues. Let's look into issues. Here you can put some notes about any errors that you find or suggestions to improve the code or something, some expansion. You can also do it in discussions. It has several categories. General, some you suggest some enhancements, or there are announcements. Here's an announcement on Gaia C4F2 decommission, and some other location where people seek help. So if it's not a specific issue, if it's if you need any help, you can put it under like general discussion. So you would start new discussion and choose the appropriate tab and give it a title and start the discussion. Next is the pull requests. We already talked about pull requests. These are your contributions to this particular repo and your suggestions. Discussions. The last is wiki page. Last but not least, it's very important because you would need to you can find out more about this particular repository, and this might be something that you would read through first when you find any new repository. The UFS short range weather app has some links to the release page, to the NoEpic website for more information about the release, SRW user guide. It's on read the docs.io. And most of the UFS repositories have documents corresponding on read the docs.io. So look for wiki and the links to these guides, user guides. And this is it. This concludes our GitHub tutorial, and the two sites that you may need to look at is epicnoa.gov, where you can find the links to the code, information on new workshops or any other community activities, code fests, and another site is on GitHub under UFS community that has many repositories under the community account. Thank you, and happy modeling and contributing to UFS.